Welcome everybody in section 5.7. Today we'll introduce you to introduction to reaction mechanism. The concept of reaction mechanism describes the elementary steps of a certain reaction. We can notice that we have two equations for only one reaction. Two steps are called elementary steps, and we can notice that one of them is slow and one of them is fast. We have to learn that the slow step is called the rate determining step. If I want to write the overall equation for these two steps, what should I do? The first step is writing the whole things over each other, so I just want to write them here again. You have hydrogen peroxide, and you notice hydrogen peroxide is an oxidant. It has a lot of applications in real life. It's used in toothpaste, it's used in rockets as an oxidant. It has a lot of application generally. How can I write the overall equations for this reaction? First of all, you have to put in your mind we have reactant side and we have a product side. So we add the product side with the product side, reactant side with reactant side. First of all, you can notice that you have hydrogen peroxide and reactant side, but we have two of them. And that's why you have to represent it in terms of 2H2O. That's really good. And then we just notice something again, in which we have I negative and the reactant and another I negative in the product. If you just notice that one of the species is in the product and one of them is in the reactant, they must cancel each other. You have to put in your mind what we call the species that are consumed first and then it's reformed again. The substance that is consumed first and then it's regenerated or reformed is called a catalyst. And you just notice that the catalyst has a mission of lowering the activation energy because it lowers the activation energy by providing another pathway for the reaction mechanism, and that's why the activation energy decreases. Okay, so we can consider that the I negative is cancelled out and I negative is a catalyst. All right. But if we look furthermore, we just notice that the I negative is not the only species that is cancelled out. We have IO negative and the products and IO negative and the reactant, and we just notice that it's produced, okay, and then here it's consumed. Okay, so the substance that is produced and then it's consumed in the reactions is called intermediate. Intermediate. Why did we say it's produced and consumed? We just noticed that since it's in the product, then it's produced, but if it's in the reactant side, then it's consumed. Okay, so what we conclude from this party so far, we can consider that the I negative is a catalyst. Okay, and that's why it's cancelled out. In addition to IO negative, it already says intermediate. Okay, and you just notice that the intermediate is a substance that is produced and consumed within the reaction. So we can say for a catalyst, it's consumed and then it's produced, but the intermediate, it's the opposite, it's produced and then it's consumed again. So let's go back again to write the whole thing of the equation. As we said, we have two molecules of hydrogen peroxide, so we write them as the RH2O2. The I negative is cancelled out, the IO negative also cancelled out, and we have to put it like that. We just noticed that we have two molecules of water, and that's why you have to represent them in terms of 2H2O in addition to the oxygen, as we can see. So the overall equation is represented in this form. At the end of this lesson, you should understand how to write the overall equation. How can you determine and how to determine the catalyst and the intermediate of your species. Let's take another example of how to write the overall equation. We can see that we have two molecules of N2O. We can put it like N2O, but we have two of them right here. And we can notice that the presence of O here and O here. So it's produced and then it's consumed. And that's why there is an intermediate. So at that point, we can say after decomposing of N2O, we have two nitrogen that are produced, and that's why we have to write them as 2N2 in addition to the oxygen. So in this experiment or in these equations, we don't have no catalyst at that point, and it's not necessary, by the way, to have a catalyst in your equation. Or now let's start with section 5.8 because these two lessons are related to each other. As we can see, we have one reaction that is composed of two steps. And now the question, how can I write the rate law for this? Generally speaking, the only thing that you have to know about this, the rate law, it's written only for the slow step. The rate is equal to, you just notice that you have K for sure, is equal to K. The reactant that you have are H2O2 in addition to I negative. That's it. So this is the overall rate law for this equation. You have to keep in mind something else. For example, like suppose that the I here is multiplied by 2. You should be committed with the stoichiometry of reaction. That's why the rate of reaction must be like this. K is equal to hydrogen peroxide concentration multiplied by I negative to the power 2. The stoichiometry of the elements is really important at that point. If I want to write the rate law for this equation, I have to look at this last step first, and then I have to say the rate is equal to K N2O, because it's the only reactant in here, so that's it, and it has a coefficient of 1 and it's raised to the power 1 at that point, and yeah, that's it. Alright guys, I hope you enjoyed the lesson. If you have any questions, you can ask in the comments below. Have a nice day.